This is a RGB sensor, and this specific model is called TCS3472. This sensor features a built-in white LED positioned precisely next to the photodiode array, which detects and measures light before converting it into an electrical signal. The photodiode array is a collection of tiny light-sensitive elements arranged in a specific pattern. Each photodiode is designed to convert light into an electrical signal. This sensor has 7 pins, which we will briefly discuss. The first pin is the VN pin, which allows you to supply a higher voltage like 5 volts, while the sensor's internal regulator steps it down to the required operating voltage. The second pin is GND, used for ground connection. The third pin is the 3.3 volts pin, used to supply power to the sensor. The fourth pin is SCL, used for the clock signal in the I2C communication protocol. And the next one is SDA, used for data communication over the I2C. The sixth pin is INT. This pin can be used to generate an interrupt signal based on specific light intensity thresholds. And the last pin is LED, and can be used to control an external LED. Next, we will explore the applications of this sensor and how it can be integrated into our projects. So,
I say, let's do it!
the TCS3472 is a digital RGB color sensor widely used in applications such as color detection, ambient light sensing, and industrial automation. Its ability to accurately measure red, green, blue, and clear light levels makes it ideal for tasks like display calibration, object sorting, to distinguish objects based on their color and categorize them accordingly, and smart lighting adjustments. Now let's explore how to integrate the sensor with a microcontroller. We'll cover wiring, communication protocols, and coding to read color data. This will help us use the sensor effectively in real-world applications. Let's begin by wiring the sensor to an Arduino. The sensor communicates via the I2C protocol, so we only need a few connections. VIN to 5V, or 3.3V on some models. GND to GND SDA to Arduino's SDA, and SCL to Arduino's SCL. Now that the connections are set up, let's start writing the code to make it work. The first step is to download the necessary library for this module. Open the Arduino Library Manager, search for Adafruit TCS34725, and install the library. Next, navigate to the Examples section in the Arduino IDE. Find the examples for the Adafruit TCS34725 library, and select the TCS34725 example provided. After opening the example, simply upload the code to your microcontroller and you're all set. With the white LED on, we can now place different objects in front of the sensor to test if it accurately detects colors and verifies its functionality. Different values are being printed in the serial monitor for red, green, and blue. Higher values for a specific color indicate that the sensor has detected more of that color in the object. For example, when the sensor detects a green object, the green value increases, and when tested with a red object, the red value rises accordingly. And for the final test, let's test it with a blue object as well. Now that we understand how the sensor works, let's build a mini project where an RGB LED changes color based on the color detected by the sensor. This will help us visualize the sensor's output in a more interactive way. First, we'll wire the RGB LED to the microcontroller, using PWM pins 9, 10, and 11 on the Arduino Uno for controlling the red, green, and blue channels. And next, we need to do some modifications in our code as well. First, we need to define the pins in the code by assigning PWM pins 9, 10, and 11 to the red, green, and blue channels of the RGB LED. Then in the setup, we will set these pins to act as output. Next, we need to map the sensor's output values to match the PWM range. Since the sensor provides values between 0 and 65,535, we will map them to a range of 0 to 255, which is suitable for controlling the RGB LED brightness. This can be done using the map function in Arduino. Finally, we will send the mapped values to the analog write function to control the brightness of each color channel on the RGB LED, making it change colors based on the detected object. Now let's test the setup by placing different colored objects in front of the sensor and checking if the RGB LED changes color accordingly. We can see that the RGB LED successfully changes color based on the color detected by the sensor, confirming that our setup works as expected. If you enjoyed this video, please like, share, and subscribe. Your support helps us grow and create more exciting electronics projects. See you in the next videos, and stay tuned for more exciting projects.